grounding electrode conductor, or GEC, is required to be connected to the nearest available water pipe electrode. However, if the water pipe is made of plastic, it is not considered an effective grounding electrode. Article 250.52 A4 of the National Electrical Code states that the grounding electrode shall be connected to the grounding electrode conductor at the service entrance or point of connection to the supply system. Article 250.52 B2 of the National Electrical Code states that where a metal water pipe is used as the grounding electrode, the connection to the grounding electrode conductor shall be made within 5 feet of the point of entrance to the building. An inspector may need to visually see the plastic entrance pipe. If an inspector cannot visually see the plastic entrance pipe, they may not be able to determine if the water pipe is an effective grounding electrode. In this case, they may require the grounding electrode conductor to be connected to a different grounding electrode, such as a ground rod. Therefore, it is important to provide the inspector with clear evidence that the water pipe is plastic in order to avoid any confusion or misunderstandings. This can be done by providing documentation from the water utility company or by physically inspecting the entrance pipe and showing the inspector that it is made of plastic. Let's delve into the specifics of grounding electrodes and the National Electrical Code requirements, focusing on situations where plastic water pipes are encountered. Firstly, understanding the role of a grounding electrode is crucial. A grounding electrode provides a connection to the earth, ensuring a low impedance path for fault current. This path helps to quickly trip over current protection devices, such as circuit breakers or fuses, minimizing the risk of electrical shock or fire. Secondly, the National Electrical Code, or NEC, outlines specific requirements for grounding electrodes to ensure electrical safety. Article 250 covers grounding and bonding, providing detailed instructions on acceptable grounding methods and materials. Water pipes are often used as grounding electrodes, but only under certain conditions. The NEC specifies that a metal water pipe can serve as a grounding electrode if it meets specific criteria. This typically includes being in direct contact with the earth for a minimum distance. However, plastic water pipes do not meet these criteria. Because plastic is a non-conductive material, it cannot effectively conduct fault current to the earth. Consequently, a plastic water pipe cannot be used as a grounding electrode. Inspectors play a vital role in ensuring compliance with the NEC. When evaluating a grounding system, an inspector needs to verify that the grounding electrode is appropriate and properly installed. This often involves a visual inspection of the water pipe to determine its material. If the inspector suspects that the water pipe is plastic, they may request further evidence to confirm this. This evidence could include documentation from the water utility company or a physical inspection of the pipe itself. If the inspector determines that the water pipe is indeed plastic, they will likely require an alternative grounding electrode to be installed. Acceptable alternative grounding electrodes include ground rods, ground plates, and concrete encased electrodes, also known as UFA grounds. Ground rods are commonly used and consist of metal rods driven into the earth. The NEC specifies the minimum length and diameter of ground rods, as well as the required spacing between multiple ground rods. Ground plates are metal plates buried in the earth and must meet minimum size requirements outlined in the NEC. Concrete encased electrodes are installed within concrete foundations or footings and provide a large surface area for contact with the earth. When a plastic water pipe is present, it is essential to ensure that the alternative grounding electrode is properly connected to the electrical system. This connection is made using a grounding electrode conductor, which must be sized according to the NEC. The grounding electrode conductor connects the grounding electrode to the service equipment, typically at the service entrance. In some cases, a supplemental grounding electrode may be required, even if a metal water pipe is present. This is often the case when the metal water pipe does not meet the NEC requirements for a grounding electrode or when the resistance to ground is too high. A supplemental grounding electrode provides an additional path to ground, enhancing the overall effectiveness of the grounding system. It's important to remember that proper grounding is crucial for electrical safety. By following the NEC requirements and ensuring that an appropriate grounding electrode is installed, you can significantly reduce the risk of electrical hazards. If you have any questions or concerns about grounding, it's always best to consult with a qualified electrician or electrical inspector. They can provide expert guidance and ensure that your electrical system is safe and compliant. To reiterate, if a plastic water pipe is present, it cannot be used as a grounding electrode. An alternative grounding electrode, such as a ground rod, ground plate, or concrete encased electrode, must be installed in accordance with the NEC. Always consult with a qualified professional to ensure that your grounding system is properly installed and maintained. Furthermore, let's consider the scenario when neutral current is present on a water pipe. This situation can occur due to various factors, such as an incorrect connection in a subpanel or a ground fault in the electrical system. When neutral current flows on a water pipe, it can create a shock hazard and indicate a problem with the grounding or bonding system. If you detect neutral current on a water pipe, it's essential to investigate the cause and take corrective action immediately. This may involve checking the wiring in subpanels, inspecting grounding connections, and testing the integrity of the grounding system. In addition to grounding electrodes, bonding is another critical aspect of electrical safety. Bonding involves connecting all metal parts of the electrical system together to create a low impedance path for fault current. This helps to ensure that all metal parts are at the same potential, reducing the risk of electrical shock. The NEC outlines specific requirements for bonding, including the size and type of bonding conductors. Bonding conductors must be properly connected to all metal enclosures, equipment, and other metal parts of the electrical system. This includes metal water pipes, gas pipes, and other metallic components that could become energized in the event of a fault. When a plastic water pipe is present, it's still important to bond any metal pipes or fittings that are connected to it. This helps to ensure that these metal parts are properly grounded, even though the plastic pipe itself cannot serve as a grounding electrode. In summary, grounding and bonding are essential for electrical safety. By following the NEC requirements and ensuring that an appropriate grounding electrode is installed and all metal parts are properly bonded, you can significantly reduce the risk of electrical hazards. If you have any questions or concerns about grounding or bonding, it's always best to consult with a qualified electrician or electrical inspector. Let's elaborate further on the importance of visual inspection by electrical inspectors. Visual inspections are a cornerstone of ensuring electrical safety and code compliance. An inspector's trained eye can identify potential hazards and ensure that electrical installations meet the minimum safety standards set forth by the National Electrical Code and local regulations. When it comes to grounding systems, a visual inspection is crucial for verifying the type of grounding electrode used, the proper installation of grounding conductors, and the overall integrity of the grounding system. As previously discussed, the presence of a plastic water pipe necessitates the use of an alternative grounding electrode. During a visual inspection, the inspector will look for evidence of a suitable grounding electrode, such as a ground rod, ground plate, or concrete encased electrode. The inspector will also examine the grounding electrode conductor to ensure that it is properly sized and connected to the grounding electrode and the service equipment. The size of the grounding electrode conductor is determined by the size of the service entrance conductors, as specified in the NEC. The grounding electrode conductor must be securely connected to the grounding electrode using approved connectors or clamps. The inspector will also check for any signs of corrosion or damage to the grounding electrode or grounding electrode conductor. Corrosion can weaken the connection and reduce the effectiveness of the grounding system. Damage to the grounding electrode conductor can also compromise the grounding system and create a safety hazard. In addition to the grounding electrode and grounding electrode conductor, the inspector will also examine the bonding system. The bonding system ensures that all metal parts of the electrical system are properly connected together to create a low impedance path for fault current. The inspector will look for bonding conductors connecting metal enclosures, equipment, and other metal parts of the electrical system. The bonding conductors must be properly sized and connected to ensure effective bonding. The inspector will also check for any signs of loose connections or corrosion in the bonding system. Loose connections can increase the impedance of the bonding path and reduce its effectiveness. Corrosion can also weaken the bonding connections and create a safety hazard. Furthermore, the inspector may use testing equipment to verify the effectiveness of the grounding system. This may involve measuring the resistance to ground to ensure that it is within acceptable limits. A high resistance to ground can indicate a problem with the grounding electrode or grounding electrode conductor. The inspector may also use a ground fault loop impedance tester to verify the integrity of the ground fault path. A high ground fault loop impedance can prevent overcurrent protection devices from tripping quickly in the event of a ground fault. In summary, visual inspections are an essential part of ensuring electrical safety and code compliance. Electrical inspectors play a vital role in identifying potential hazards and verifying that electrical installations meet the minimum safety standards. When it comes to grounding systems, a visual inspection is crucial for verifying the type of grounding electrode used, the proper installation of grounding conductors, and the overall integrity of the grounding system. By conducting thorough visual inspections and using testing equipment when necessary, electrical inspectors help to protect people and property from electrical hazards. Therefore, understanding that electrical inspectors are not being difficult but are performing a vital public safety role is crucial. The National Electrical Code constantly evolves to account for new technology and improve safety.